Okay, so let's take a look at number one, and hopefully that will help you through the rest of these. So, question one, we want to test the claim that the proportion of men who own cats is larger than 30% at the 0.005 significance level. Okay, so let's notice that we are testing a proportion claim. So we want to choose the hypotheses that have a p for proportion instead of a mu for a mean. All right, so since it's a proportion, and we want for our alternate that the cats are larger than 30%, the proportion is larger than 30%, then we're looking for an alternate that is greater than 30%. So we are looking at this one right here where P is greater than 0.3. All right, so this one would be our null and our alternate hypothesis, and all of these, since they are proportions, will have P's in them. It is with a greater than, a right-tailed test, so you got that part right. All right, so let's look now at doing our test statistic. And so let me write down the test statistic for you. So since it's a proportion, we are going to use our p hat, which is our sample proportion, 34% in this case, minus p, and I apologize for my first grade like writing on here, over the square root of p times 1 minus p over sample size n. Okay, so our p hat is the 34% we got. Now, if it doesn't give you p hat, it might say something like, based on a sample of 50 people, 13 owned cats, and you would do 13 divided by 50 would give you that sample proportion. But in this case, it gives it to us. So I'm going to put it down here. Let's see, we'll have 0.34 minus 0.3, which is our proportion from right up here. And then on the bottom, we'll have the square root of 0.3. 1 minus 0.3 will be 0.7. And the number in our sample is 50. Oh, it tends to do this sometimes. Let's see if we can fix it or not. Yeah, there it goes. I think it's because I'm getting close to the edge of the screen or something. All right, so let's see if it'll let me put it in. There we go. All right, so the top of this is going to give us 0.04. And the bottom, when I put the square root of 0.3 times 0.7 divided by 50 in my calculator, is 0.06 481. And then if I do that final division of those two, I end up getting, as my test statistic, I'll just put it right here, 0.61719. All right, so there's my test statistic. It looks like it's the proportion, or it looks like it's the probability, but it's not. It's the test statistic. Okay, so the critical value. All right, so this is a right-tailed test since we said this was going to be the greater than here. All right, and I don't want to look up 0.005, although I could. It'll give me the negative z value, and then I could just switch it to positive. Let's just do that. So I think I have to exit the drawing here. So in Excel, I can either put in the 0.005. It'll give me the negative z-value, and I can just switch it to positive since we're dealing with a right-tailed test, or I can put in 0.995, which is 1 minus 0.005, and it will give me the correct value. We'll just put in the 0.005, get the negative. So we'll have norm.s.inv. I'll put in 0.005. It's going to give me the negative z-value, and we want the positive since we're dealing with a right-tailed test. And I think it said to round to 2 decimal places, so we'll have 2.58. All right, so let me go back over here. 2.58. I'll write back down. It unfortunately, when I turn off the draw, it makes things disappear. So this one, if we rounded to 2 decimals, was 0.62 for our test statistic. Our critical value was, what did I say, 2.58, I think. All right, now, since it's a right-tailed test, we need for it to fall in the rejection region. It has to be to the right of 2.58 over here. And of course, our test statistic is certainly not to the right of 2.58. It's over here. All right, so we fail to reject the null hypothesis since it's not in the rejection region, which means, of course, that there is not enough evidence to support our alternate hypothesis that the proportion is greater than 0.3. And hopefully that will help you to get through these.